Let's go ahead and start talking about section 4.1. We're talking about what exactly is average. So it depends if we're talking about the mean of a data set, the median of a data set, or the mode of a data set. All three of those measurements can represent the average of a data set. So let's talk about how different each of those are and what does it mean to compute them. So if we're talking about the mean, this is the one that people most often think about if you hear the word average. This is going to be the average or the arithmetic average of quantitative data. What we're doing here is we're taking the sum of all the data values excuse me, sorry guys, been a little sick lately. And then we want to divide it by the total number of values. So we're going to take the sum and then divide by the total number. This measurement is going to be affected by outliers. And an outlier is just like we would think about in non-mathematical terms. So it's going to be something that is different or dramatically different than what would be considered the norm. So it's values that are either significantly higher or significantly lower than most other values. We could also calculate the weighted mean. And it's different, a weighted mean is different than a regular mean, just because each category is going to have its own assigned weight or its own relative importance. And you've seen this a lot in like grade calculation. So it might say something where a grade is 20% from tests, 30% from homework, and so on, right? So every different category has its own level of importance. What we would do here is it's pretty similar to what we would do for a mean, except instead of just taking a sum of all the data values, we need to take a sum of each data value times its weight. And then divide by the sum of all weights. And we'll do some examples with that once we get to the practice. We could also find the median and the mode of a data set. Median is just like we're thinking, again, non-mathematical terms. If we have like the median of a road, for example, that's going to be that middle portion of the road. It's the same mathematically. We're talking about the middle value of a sorted data set. So it can't just be in any order. It has to be sorted. And this is also for quantitative data. Because we can't sort qualitative data, right? So if we're trying to put it in some sort of a logical order, it wouldn't make sense if we were talking about colors to say, well, orange comes before blue just because we want it to, right? So we have to be able to sort it in a way that makes sense, which means that data must be quantitative. There's two different things that can happen, right? So if we're looking at a median, we could have a data set that has an odd number of values. So for example, 1, 2, 3, 4, 5. We sorted it from smallest to largest values. And here it's easy to see that that median is the value that's right in the middle. So here our median would be 3. But what if we have And this one's going to be different than the one I have written in the notes, but what if we have an odd amount of data values, or an even amount of data values, I'm sorry. So if we're looking at an even amount of data values, I can't just say, oh, well, this one is in the middle like I could before. I can say, well, these two values are in the middle, but I'm not going to have two medians. There is only one middle value. So whenever I'm looking at an even number of values in that data set, I need to look for whatever value is between those two values. So here, we would take 3 plus 4 divided by 2, and we would have a median of 3.5. A median is not affected by outliers. And that's because if we have a value that's far off on one end, even if it differs a lot from the other values in this data set, it's not going to affect what value lies in the middle. So it doesn't matter if we have any extreme values on one side or the other. The mode is also not affected by outliers. So the mode, we could talk about qualitative and quantitative data. And we are talking about the most common value or values. Since it's just the most common, it's going to be the most occurring one. And so here it doesn't matter if it's quantitative or qualitative, right? If we're talking color of cars and we have 4 orange and 2 blue, I could say, well, orange is our mode. It's the one that occurred the most frequently. Let's go ahead and jump down to section 4.2. I'll clear the screen. So in 4.2, we're talking about the shape of a distribution. So we're going to start to see curves now. Just know that when we're talking about the shape of a distribution, it could be from a histogram, for example. So let's say that maybe our histogram looked like this before. If we're wanting to talk about the shape of a distribution, it's as if we were just getting a general idea of that shape. So instead of working with rectangles, we're now just going to work with curves. So in shapes of distributions, the shape can be determined by 3 different characteristics of the data set. So we can talk about the number of modes, and remember that the mode is the most common. Occurring value. It could also be determined by or described by symmetry or skewness, and we'll talk more about that in just a second. And lastly, the shape can also be determined by the variation of the data set. Let's go ahead and talk about the way that different graphs would look based on the number of modes. And I'm going to talk about 4 different scenarios here. If the distribution does not have any modes, what we're saying is that every value occurs the same number of times. So there is no value that occurs more than any other value. In that case, the shape of the distribution is just going to be a straight line, right? They all have the same number of frequencies. So this would be considered a uniform distribution. if we have one value that occurs more than any other, now what we have is a unimodal. Look at that prefix uni, so we're thinking one, so it's unimodal. We could also have a bimodal distribution. So now instead of just having one curve or one hump, we now have two values that occur the most frequently. So we have two modes. And lastly, we can have a trimodal. And it's just as you would expect. Here we're going to have three values that occur more than any other value. Anything after that we consider to be multimodal. So you often won't see anything that says quadrimodal, for example. We'll go ahead and change this color. And we'll talk about the symmetry or skewness of a data set. If a data set is symmetric, then we're going to say that one side is a mirror image of the other. So, for example, I could have a bimodal distribution, and if I were to separate this curve into halves, we would have that right side as a mirror image of that left. If we have skewed data, that means that our two sides are going to be different. So there's two things that can happen here. We could have right skewed data, and we could have left skewed. When we're talking about skewed, what that means is we're being pulled by outliers. So we're going to say if it's right skewed, we have some outliers over here on the right, but most of our data is on the left. So our tail is over here, which is where some outliers are going to be. That's why our frequency is lower over there. So we have the mean is closest to the tail, because remember that it's pulled by outliers. We have the median. And then in the middle of that hump, we have the mode. So right skewed means pulled on the right, or tails on the right. On the contrary, if it's left skewed, now we just have a couple values that are over here on the left, but most of our data is on the right. So we're skewed by the outliers over here on the left, with a tail or outliers. And then again, we could say, well, if we have outliers on the left, then our mean is closer to the outliers. The median is always that value that's in between, and then right in the middle of that hump would be our mode. Let me go ahead and clear this screen and move down a little bit more just to talk about variation. So I'm going to rewrite variation up here. We're talking about the variation of a distribution, or how the variation affects the shape of a distribution. What we're first talking about is we're talking about how spread out, or how much variance there is in the data set. Let's say that we have a low variation in our data. Then most of our data is going to be within a small range, right? So most of our data is going to lie in one general area. And we're talking about it being from the center of the data set. So if we're talking about a low variation, we could see here that most of that data in this data set lies close to the center. If we have a high variation, then what we're saying is that our data is more spread out. So instead of it being centered, it's more spread out, right? So now we can see that most of our data is here. So there's not as much variation when it's all centered around the center of a data set, and there's more if it's spread out. And we'll talk more about that as well in some of the practice problems. So this is going to end the lecture portion of 4.1 and 4.2. Go ahead and take a second and try some of those practice problems before you just jump into the explanation of them. That is going to be one of the best ways to learn, is to try to figure out some of those problems on your own first, and then kind of check and compare once we get there together.